Hi, this is Vasavi from At Home. So let's take a new chapter today, triangles. Here I'm going to talk to you about the similar triangles. Two polygons of the same number of sides are similar if their corresponding angles are equal and their corresponding sides are in the same ratio. That means the sides are to be in proportion, okay? So, when do you call two polygons? Polygons, I hope you know, any closed figure with few sides, you call it a polygon, right? With all straight lines as its sides is called polygon. If I say polygon, even square is a polygon, a pentagon is a polygon, right? So, when you take the polygon with same number of sides, remember it is same number of sides, then they are similar. For that you have two conditions. One is that they corresponding only if their corresponding angles are equal. Say for instance, if I have taken another pentagon, okay, another pentagon, okay, here only if the angles, the corresponding angles are equal, okay, these corresponding angles are to be equal and, okay, their corresponding sides are in the same ratio. The sides should be in some ratio, okay. If this is 2 and this is say 6, here if it is 3, it should be 9 over here, okay. The ratio between the sides, corresponding sides should be the same. I can explain this more. So for a similar polygon, okay, any other, whatever the shape may be, if two polygons have the same number of sides, to say that they are similar, you have to satisfy two conditions. One is that the corresponding angles should be equal, and secondly, the corresponding sides are in the same ratio, and this ratio we normally call it as scale factor. That is also mentioned here. Note that the same ratio of the corresponding sides is referred to as the scale factor, or you can also call it representative fractions, okay. Normally we call it scale factor only. So here I have taken two squares, okay. Let us see, say for instance, if I say the sides of the square here is 3 meters, okay. Since it is a square, all the four sides would be 3 meters, right? Okay. And for this, if I say, I take it as 4 meters, okay. If these are 4 meters, I would say that these two triangles are similar because you can see that the corresponding angles over here are equal, right? These two are 90 perpendicular. You know, for a square, all the four sides are, four angles are 90 degree. And this angle is equal to this, okay. The corresponding angles are all same. So our first condition is satisfied, okay. The angles are equal. And the side, corresponding sides. So if I take this side, I should take this, okay. So let me see, it is 3 over 4. And the other side, if I take this one and this one, it is again 3 over 4, which is equal to this. Okay, and you see that all the four sides are in 3 by 4 proportion. Okay, 3:4 proportion. And this ratio, this 3 by 4 ratio is called the scale factor. Understood? These two squares are similar because the angles are equal and the corresponding sides are in proportion. Okay. Now here you have hexagon, two hexagons. And I can say that all the angles of the hexagon is same because this seems to be a regular polygon, right? Regular hexagon, because looks like all the sides are equal. The sides of this hexagon are all the same. So the angles also would be the same, okay? All these angles would be the same. And what would be the angle, one angle of a regular hexagon? So you have so many formula for doing that. The one formula to find sum of interior angles. The formula is n minus 2, where n is the number of side, minus 2 times 180, right? So this one is a hexagon. So you have 6 sides minus 2, okay, take away 2 times 180. So that is equal to 4 times 180, okay. So that would be 720, right? 720 degrees. So this is for the total, all the angles. So for one angle, therefore, one angle, since all the sides are same, you can divide it by the number of sides, right? So that would be 720 divided by the total number of sides is 6. So that will be 120 degrees each. Okay? So this is 120 degree each. Same way, this is also a regular polygon because all the sides seem to be same. So the same procedure you do, and here too you get the angles same. Okay. So this would be 120 degree because the length of the side has no effect on the angles to be found here, right? So here you see, even though this hexagon is small and this regular hexagon is big, all these angles are going to be 120 each. Okay. So now your first condition is satisfied. So this condition is satisfied. Your angles are all corresponding angles are all same. And about the side, say for instance, I say this is x. The side is x, and for this I call it y. Okay. This side I call it y. So the ratio here. So if this is x, all the sides, since it is a regular polygon, all the sides are x, right? So here too all your sides would be y. I repeat, this is because it is a regular polygon. Okay. If it is not a regular polygon, you cannot have all the sides equal. So that we'll see later. So to make this theorem clear, I just mentioned this. Okay. I have taken the examples of regular polygon. Now when you write the corresponding sides fraction, it would be like x over y, right? All sides are in this ratio, x over y ratio. So your scale factor here is x over y. Understood? So you have a scale factor, that is all the sides are in the same proportion and the angles are equal. So your two conditions are satisfied, and hence you call these two hexagons similar. Okay? And make it a point, you can note this one. Regular polygons are always similar because they have same number of sides and all the sides are equal. So the ratio is going to be the same for both the polygons, and the angles are always the same. So your two conditions are satisfying. So any regular polygons, may it be a square or a rectangle or a pentagon or a hexagon, whatever you take, they are all similar in nature, always similar. Understood? So let us make this clear by taking few problems. Okay, let's check this. You have to state if the polygons are similar. Okay, so you have to see whether the two conditions are satisfied. So here you see that this angle is equal to this angle. Okay, so one angle is equal, this one is equal to this. I just denoted with different signs. So here this one is equal to this, and this one is equal to this, right? So you find that four angles are same. Let's check whether the corresponding sides are proportional. Okay, so the shortest side, let me take the shortest sides first. So 25 is the shortest side for the first bigger triangle, and the smaller triangle, the shortest side is 20. So the ratio would be 20 over 25, or you can even write 25 over 20. Okay, so I have written small trapezium by the big trapezium, that formula. Okay, so this is 4 over 5, right? This is equal to 4 over 5. That I'll write later. Now let us take the bigger side. Bigger side is 28 over 35, right? The corresponding sides I have taken. So this 35 and this 28. Okay, so that's 28. You have to write the smaller triangle on the top and not triangle, sorry, trapezium on the top and the bigger side of the trapezium down. So I have written that. So both the sides are same. So I can just take one, okay. So here again it is 12.4 over 15.45, sorry. So these ratios, if you check, this goes in 5, right? When you divide by 5, this is 4 over 5 ratio. This you are going to divide by the common factor 5. This you can divide by the common factor 7. Here you can divide them by the common factor 3.1, right? So when I divide with the common factor like this, I get my ratio as 4 over 5. Did you understand? So this is the scale factor of this trapeziums, these two trapeziums. So I see that that all the sides are in the same ratio 4:5 and all the angles are same. Therefore, they are similar. Okay, I can say they are similar. Okay, so this is done. Let's go on to the next one. Here this is two rectangles, right, with different size. So the angle, since it is a rectangle, you know that all the angles are same. Is that not? So the corresponding angles are all 90 degrees. So your first condition is satisfied. Now let's take the sides ratios, right? So I take the smallest side is 18 over 24 and the next smallest side is 24 over 36. So when you simplify this, you can divide this by 6. So you get, when you divide this by 6, you get 3 over 4, right? And here when you divide by 6, no, it doesn't, it is not 3 over 4. So the ratio is not same, okay? 18 over 25 is not equal to 24 over 36. So therefore sides are not, I can say sides are not proportion. Therefore they are not similar, okay? So this is not similar because the sides are not proportion. Now let's take this C. Next problem C. Here let us first look into the sides. So the smallest side is 5 over 15 is equal to 7 over 21, right? So you can divide this by 5, you get 1 over 3, and here when you divide by 7 you get 1 over 3, okay? So this is your scale factor. So the sides are proportional. Let's look into the angles now. So this angle is given already. We can find out this angle, right? So this angle should be these two co-interior angles. So they together should make 180, right? So this should be 50 here. But here you say this angle is 140. This itself shows that the angles are not equal. Even though the sides are proportional, since the angles are not equal, they are not similar. So this is how you check whether two given polygons are similar or not. So I repeat, the condition is that the sides should be proportional and the angle should be equal, okay? Now this is another type, like the polygons in each pair are similar. They just want you to find the scale factor of smaller figure to bigger figure. Remember this is smaller to larger figure. Okay, now since these polygons are equal, the angles you don't bother, you know that they are equal. So let me complete this, all the sides, okay? So this should be 12 centimeters, right? Here this is 6 centimeters. And here again it is 4 centimeters. So let us see if the angles are same. Okay, you have two conditions. Angles are same and the sides are proportional. you're going to find the scale factor only. You are not bothered to check. You needn't check whether the sides are proportional and the angles are equal. They say it is similar, so that means it should be. Okay. Now, the scale factor, you have to write smaller to larger figure. So, the smaller figure is 4, and for the larger figure, the corresponding side would be 12, which is equal to 6 on the smaller and 18 on the bigger. When you simplify this, you get 1 over 3, right? So the scale factor is 1 over 3. Understood? This side again, let me fill in the sides. So since the triangles are similar, scale factor is equal to smaller side divided by the largest side. Okay? Or you can say 8 over 40. The next side is also 8 only. It must be 8 only. Since the bigger triangle is isosceles, the smaller triangle should also be isosceles, and that should be 8. So that doesn't matter. You just need to find the scale factor, right? So this is going to be 1 over 5. When you simplify, you get 1 over 5 as your scale factor. Hope you all understood what a similar polygon is, and the similarity for similarity, the two conditions you need for a polygon is that the sides are proportional and the angles, corresponding angles are same. Okay, and you have one more, congruent triangles. Unlike similar triangles, congruent triangles, the angle should be same. That is same for both. But in a congruent triangle, even the sides are to be same. Okay. But here, since we are doing similar triangle here, let us for time being forget the congruent triangles. Here the corresponding sides are proportional. See you in the next video. Bye.